Alrighty, well, let's get started. First of all, thank you everyone for joining. We're super excited to have everyone tuned in. Welcome to the Coinbase Developer Platform event series, and today we're excited to showcase x402, enabling frictionless autonomous payments for APIs and AI agents. We'll walk through what it is, see real demos, and help you get started today. Now, first, let me introduce you to our speakers. First, we have Lincoln Murr. Lincoln, if you want to go ahead and do an intro and what you worked on for x402.
Cool. Hey everyone, great to see you all here. My name is Lincoln. I'm the product lead for Coinbase Developer Platform's AI initiative. Been working on AgentKit and x402 for the past several months. Super excited to be chatting to you all today about all the different things we have planned for x402, what we have out today, and where we're going.
Awesome. Next, we have Eric Rappel.
Hey, I'm Eric. I'm the head of engineering for Coinbase Developer Platform. Also built the prototype for x402 and have been having the project since its inception back in February.
Awesome. Then we have Ronnie Kaspers.
Hey everyone, my name's Ronnie. I'm a product manager on the Coinbase blockchain platform team. I spend most of my time making high quality blockchain infrastructure to process transactions and serve most of our product suite. Before Coinbase, I actually come from the land of traditional fintech payments, so I'm very excited to be working on the x402 facilitator and seeing how we can bring a much better agentic payment flow to the internet.
Great. Thank you, Ronnie. Next is John Peterson.
Everyone, I'm John. I'm an engineer on CDP. I'm the engineering lead for AgentKit and the technical lead for the x402 facilitator. So really happy to get this out in the public and get everyone settling transactions on chain.
Amazing. Thank you all so much for your intros. We also have a few partners today. We have Jordi Montes from Proxy 402, Arthur from Neynar, and Amar from Hyperbolic. Now, here are some topics we'll go over today. We're going to have an intro about x402, so explain the motivations behind its creation, what it enables, and why we believe it's the future of agentic interactions. We're going to have a discussion with the x402 team. We're going to showcase what our partners have already built, and then we'll have a Q&A at the end. So like I mentioned earlier, if y'all have any questions, please make sure to put them on the right-hand side of Discord, and we'll go over those at the end. Some housekeeping, just make sure those questions are relevant to what we're discussing today. Without further ado, I'll be passing it over to Eric to have an intro about x402.
Okay. So this is a talk of the third time I'm giving this talk, so hopefully the best time. I think a lot of x402 comes from this motivation of like building a agentic internet. And I think that if you go to the next slide, Ellie, there's a context here, which is the internet was designed for humans. Broadly, I have the belief that agentic usage of the internet is good. And by creating new standards, we can make the internet better for both humans and agents. Slide. So what is the internet? Back in 1987, the World Wide Web project was launched out of CERN. Next slide. And so what actually was the World Wide Web project? It was HTML, HTTP, and a www client, now known as a browser. And these are all standards. Maybe we can find like a way to just signal to you that I want next slide. Set of standards for computers to communicate each other, to display informations to humans. Slide. This is what came to be known as Web 1.0, which is the read layer of the internet. This is like, originally the internet was started to show research documents and other papers and share them across institutions located mostly in the US, but also in Europe. Slide. And then Web 2, which I think you can track the origins to about 2008, introduced the right side of the internet. So this was JavaScript for interaction, Ajax for communication, JSON for a readable format. uh, of data transmission slide. And the point here is really that the web evolves through standards. And each one of these components is like a standard for accomplishing some task. So HTML is a format to represent data so that it can is visible to humans. HTTP is a standard for transportation of data between computers. Browsers are a standard of receptacle or way to receive data and for data to be delivered. JavaScript is a standard for interaction, Ajax for access, and JSON for format. Slide. The current web standards were designed for humans to operate computers, and we're now in a world where both humans and computers operate computers. So you might be asking, Eric, like why is it so hard for humans to understand the web? Why is it hard for LLMs to understand the web? And on the left is what you or I see. And on the right is what a machine sees, or what an agent sees. On the left, we have the DoorDash website. You know, it's got a lot of images. It's got like some text. It's a pretty nice website. On the right, we have the HTML that actually underlies that website. And the human looks really happy, and the robot looks sad. And I went and ran that HTML through a token counter. And the HTML on that website there are 600,000 tokens. If you use like Anthropic or OpenAI's API, it's roughly $3 per million tokens. Even just reading that website, if you're an agent or an LLM, costs you $1.87 unless you pre-process it. Slide. You popped out there, Ellie. And it also suffers from this thing of what's called the needle in a haystack problem, where it's very well understood that LLMs do pretty poorly if there is irrelevant data to them in their context window. So if you take those like 600,000 tokens, maybe about 1,000 of them are relevant to what data is actually required to convey to a machine. Like they probably care what the restaurants are available, what the like various wait times to order from a restaurant are. 1,000 tokens is like 0.16% signal to noise ratio, because HTML on the bottom right contains all this information on styling and other things that are needed for browsers to display information to humans, but not needed for LLMs to understand what's going on. Ellie, you're not on mute, and you keep kind of cutting in. Thanks. And so, this kind of leads to the situation where you have like expensive and low quality, and this means that LLMs tend to not perform super well. And this is because, in part, low signal to noise, but also LLMs and other machine learning models move what used to be deterministic systems to probabilistic systems. So if you write a piece of software, it's largely going to do the same thing every time you run it. It's a deterministic system. If you write a script that prints out 1, 2, 3, 4 to the console, it's going to do that every single time if your hardware is the same. But with an LLM, you get a probabilistic system, which means that there's a probability of something happening when you give it a prompt. And it won't always happen the same way. And so an LLM may work correctly on the first time that you give it a prompt and have it do a task, and not correctly the second time you do it. And that's largely because like each token is conditional on the tokens prior, and there's entropy in the system in evaluating and selecting tokens that are chosen for output. And so, maybe your model will work 85% of the time, but that's not 100% of the time like it is in a deterministic system. Slide. And you may be saying, Eric, like, well, why won't you just use vision and browser rendering? And I'd say like that's a worthwhile path to traverse in the make the internet great for models arena, but it adds a lot of complexity. So you now need a browser to render all the HTML pages. You need to like take an image of that browser render and feed it into an LLM. you need to give the LLM access to like keyboard navigation or mouse emulation or accessibility based navigation. I was actually on a panel last night with Edwin from OpenAI, and he was like, "Yeah, operator from OpenAI still isn't very good at like clicking on a keyboard. Because again, these are probabilistic systems. The more things they need to do, the harder it is for them. And there's like 10 other things about building vision-based systems that make it quite difficult to uh, create agents that use the internet like a human does. Slide. The slide, Ellie. So it's not as simple as just using vision. And the kind of frustrating thing is like anyone who's built a web app knows that the data is there. Like the optimal data for a model actually already exists in a database in a machine readable format. The DoorDash website on the left is actually like exists in Postgres or MySQL or whatever DoorDash uses in a way that's pretty well in a format that's well optimized for an agent to receive, and then goes through a process of rendering that data, typically with like React or Rails or Vue or some other framework for creating web applications. Slide. The data is there. The files are in the computer, and you can like get angry about that, or you can say like, okay, it's there. It should be simple. Let's make it simple. Slide. Right now, there's no incentive to expose that data. For most things on the internet, value is gated. There isn't actually a reason to give away your data if you don't have to. In fact, like bots have been considered harmful for the entire history of the internet so far. Now we have this concept of agents, and people are like, "Oh, well, we'll get better automation, and like that'll increase market value." And everyone's kind of scrambling to figure out a way to give agents access to their apps, access to their data. Um, and so this is why we're running into this whole thing of like, how do you make the internet good for agents? Slide. And I'd argue that payments are the worst part of the internet. Slide. If you've spent any time on the internet, you've gone through a checkout flow that looks like this, where you collect a credit card number, a billing address, et cetera, et cetera. Payments are the most important unlock of the internet, but they're also by far the most human in the loop. Next slide. If you look at this form, there's actually 14 fields you need to fill out, and the UX is bad for humans. The repeat UX is a little better. Things like Stripe Link and Shop Pay make it so if you're a returning customer, you know it can be like 2 or 3 fields and a 2FA code rather than 14 fields. But it's a worse agent experience. Next slide. And agents need to be really good for you to trust them with your credit card. If you if you give an agent your credit card, it could spend up to your credit card limit. And credit cards aren't exactly programmable and native to the web, and so it's kind of difficult to make them safe for an agent to use. And so this blocks what I call the rise of dynamic agents. So what is a dynamic agent? The place to start, next slide, is uh, is where we are right now, which is what I would define as static agents. So an agent is a set of static functionality with manually integrated tools chosen by its developer, capable of handling specific problems. Next slide. A dynamic agent is an agent with a set of dynamic functionality and task determined tools chosen by the agent rather than by the human that's capable of handling arbitrary problems. Slide. So if we take the example of make a joke that involves tomorrow's weather and today's price of S&P 500, you need to create a discrete agent to do this. And if you've ever built an agent, first step is go and find the tools that will give you the weather and stock data, because that's not a thing in the training set of the LLM. It can't know current and future things just inherently due to how LLMs are trained. Then you have to integrate the tools, and then your agent can use those tools to fetch the data and make a joke. The dynamic agent actually chooses the tools, integrates them itself, and then performs the task. Slide. You might say, like, why doesn't MCP solve this? Well, partially. MCP is a good standard. MCP standardizes an access pattern. It doesn't involve discovery, authorization, or payment of underlying tools. So if you've ever written something or used MCP in with like Claude or any other client, typically you end up with a config file that looks something like this, where you declare a bunch of tools, you declare an invocation command. Next slide. Then critically, you specify an API key. And this like API key is really like I think the limiting factor on MCP discoverability, because you now have like a scenario where uh, you have to intervene and go register an account yourself, generate an API key, give a credit card, et cetera, before your agent can actually discover and use these services. This is again most valuable functionality on the internet requires payment. And today, agents can't make API keys, thus agents are static. So back to the thesis of this, it's time to start adding new standards to the web with AI agents in mind. Next slide. So this is where we get to X402 with all that preamble. X402 is an open payment standard for the internet. Next slide. So way back in I think 2014, when HTTP 1.1 was being enshrined, they added the 402 payment required status code to the HTTP spec. With this line is the only description of the 402 status code. The 402 payment required status code is reserved for future use. They knew that they would need to solve payments on the internet, but there was no way of doing that at that time. Slide. And Mark Andreessen has this famous quote. So let's say hypothetically you want to have an online newspaper article and you want to read that article in that paper, and maybe you want to have an economic relationship where you're paying for that information. I would think it was the most obvious thing to do is to build into the browser the ability to spend money. But you may have noticed that didn't happen. So I think the original sin of the is that we couldn't build economics, which is to say money, at the core of the internet. Slide. So now we get to X402. 14 years later, we're at a point where technology actually is good enough to start building these standards for payments on the internet. Slide. And so what you'll see here, chances are a lot of people in this room have either seen this demo or gone and done it, is a paywall payment experience where you can pay 1 cent to listen to a song that Dan Kim, uh, one of our team members on Go to Market made. And the thing here is like that is revolutionary is not that it's a like crypto checkout flow. Slide. It's that the checkout flow is identical whether you're a human or the agent or an agent. I, as a human, can go through that flow in about 3 clicks. I, if I'm building an agent, can pay for that content in one line of code. If you're using the X402 Axios or Fetch wrappers, you just need to wrap your HTTP client with a wallet. And now you can pay for the same things that I did as a human with equally as good of an experience as an agent. Next slide. So you go from this 14 line payment checkout flow, 14 field payment checkout flow to either 3 clicks if you're a human or 2 lines of code if you're an agent. This makes things obviously significantly better. Next slide. So that's what X402 does. Is it has 0 fees as a protocol. It has a 1/10 of a cent as a minimum payment for now. HTTP native. It lives in the requests you're already doing. It's blockchain agnostic, and it's flexible enough for future use cases of payments. Critically, it's a better UX for both agents and humans to pay for things on the internet. So how does this work? Well, in short, blockchains have gotten really good, and the internet has gotten really good. And X402 is the link, the bridge between the internet and blockchain-based payments and other payment rails. So under the hood, what X402 actually is physically is a 402 status code with a standardized JSON body. Then in the request, a header that contains a signature that contains authorization for payment, and then an abstraction for settling that payment so that the person accepting funds doesn't have very much complexity. And so we talked about this concept of a dynamic agent. And this demo, which will don't worry, well, there's screenshots of it in the next one. It was checked into the repo. Uh, is an example of exactly what I talked about with dynamic agents. So this is an agent I built in about 15 minutes. Has two tools. One of which lists the tool, that's the index tool, lists all the APIs that this agent is able to pay for. The second tool is HTTP tool, which allows you to make HTTP calls to different APIs and inline pays for things using x402. So you'll see on the right side, or you'll see at the top, the prompt is simply, you are a helpful assistant. You have access to an index of APIs that you can use to dynamically get data, make a pun based on the weather in San Francisco and the price of SPY. You'll see in the output on the right, the agent first lists all the available resources, and then it makes an HTTP call to check the weather, and then it makes a call to get this price of SPY. Both of those are paid for in line using x402. And then it makes a pretty bad joke about the weather and price of SPY, but it's kind of a forced premise anyway. I don't blame it too much. The point being, this agent has no prior knowledge of a tool about weather or a tool about stock data, but is capable of doing multi-tool usage and accessing data from multiple sources dynamically rather than knowing those tools ahead of time. And if I could have given it any prompt here, and if there was a rich index of x402 payable APIs, it would be capable of doing a large variety of tasks beyond what is doing right now without actually altering the tools. Next slide. X402 helps with dynamic agents. It's 2-click payments for humans. And we can go to the next slide. It's a standard that agents that we should adopt, and part of this paradigm of agentic standards for the internet that'll improve the internet alongside MCP. And we should be thinking about more of these things. I think x402 has a good shot at being a payment standard for payments on the internet, but there are likely more things that we should consider that extend the internet further to be a great place for both humans and agents. Next one. So, to repeat again, by creating new standards, we can make the internet better for both humans and agents. Next slide. If you haven't seen x402.org yet, I'm not sure why you're in this call. Check out the GitHub, cdp.coinbase.com for everything else Coinbase Developer Platform does. And then you can follow me at Programmer on X and Farcaster. Thank you very much.
All right, so I think it's time for our demos now.
Hello, everyone. I'm Arthur from Neynar, or Quasi on Farcaster and GitHub. We provide services for the Farcaster network, and we're super excited about the possibilities x402 unlocks for social. So between x402 and the upcoming Coinbase wallet integration, now's a pretty exciting time to get on Farcaster. Before we get started, I just wanted to thank everyone here today from the Coinbase team for their help integrating x402 with our API. And this demo is pretty straightforward. We've basically just added x402 to all our endpoints, and we'll show accessing a few of them today. The flow is basically the same as the one that Eric's already shown, so we'll keep it pretty quick if you want to start the video now. So these are our docs. Anything that's available on these docs you can access with x402 as of today. We're going to start off with a request to get all Farcaster channels. Farcaster channels let users group posts by categories. You could imagine making a Farcaster mini app that presents some channel suggestions based on this and some user data. And again, same flow that Eric showed before. This makes a lot more sense programmatically through an agent or something, but we're just showing it in browser for the time being. And then once we get this channel information, the next thing that we're going to do is we're going to show getting some user data. This is just getting my user data. So we'll look up based on my Farcaster username, and then we're able to get my FID. And then once we have that FID, we're just going to go ahead and get some information about the channels that I regularly use on Farcaster. And as you can see, all of these endpoints are x402 enabled. Beyond these basic displays, some of the things that we're super excited to see people build are not just agentic or programmatic flows, but also the fact that mini apps on Farcaster can now be paid for by the user. So you could imagine a mini app that allows people to schedule posts or casts into the future, and then the user's paying for that instead of some sort of service. Also, agent usage is super exciting. Since there's rewards on Farcaster, you could imagine an agent that's basically paying for its own usage based on the engagement that it gets. It receives rewards, and then it can allocate those rewards to hit our endpoints, figure out what to be posting, and then get more rewards. So it's like a self-sustaining agent, which is super, super exciting. That's basically it. Like I said, we'll keep it relatively brief. Call to action, just check out our docs and give it a try. We're excited to see what people build. Thanks.
Thank you for that. Okay, cool. So we have a few other demos to go through.
So hi, my name is Am from Hyperbolic, the Amrthadi on Twitter. So today I'm going to be showcasing our Hyperbolic x402 integration, which allows you to access many of our inference models through x402 without an API key. So as you can see here, this is our models front end. So we have different open source models, DeepSeek, Llama, many other models, for VLM, base models, audio, etc. And then there's a demo that we put together here. Hopefully the system audio is shared. Hey there, my name is Am from Hyperbolic, and today I'm going to be showing you our Coinbase x402 integration. So the first thing you need to do is set up our proxy server to point to our API. So we're going to run this command to set our config, and we're proxying successfully. And then in this second terminal, we're going to run our example payment script, which is going to send a request to our DeepSeek v3 model, querying with what can I do in SF. And as you can see, we've returned the 402 error, no payment header found. Our payment script is going to add that header, and now the payment has been verified and it's proceeding with the inference with a cost of 0.001 USDC. So now we've received the response from our API with status code 200, and you can see now what we can do in SF. So this opens up so many possibilities for autonomous agents to send requests to our inference APIs without having an API key, building the future for autonomous agents and beyond. Were you guys able to hear that?
Yeah.
All right, yeah. So the Hyperbolic's integration with x402 allows you to now access many of our models. We have over 30 models, and you can access them through an agent without an API key, which allows agents to have this form of people define as AGI or whatever you'd like to call it, but it's more of a fully autonomous agent that does not require any user intervention to gain additional knowledge or gain additional processing power on its own. And through Hyperbolic, you can have an agent that can rent its own compute, as well as run models on its own compute. And through this x402 integration, there's so much possibility for these models to make their own decisions on when they want to rent, when they'd like to query, and opening up that ability for them. And we're excited to work towards a mainnet integration, and hopefully soon we can have everyone accessing Hyperbolic on x402.
Super cool.
And thank you to the whole Coinbase team for their support throughout the debugging and building of this demo.
Thank you so much, Amar. All right, Positive Blue.
Excellent. I think that now you can hear me, right?
Yes.
Okay, finally. Sorry, I'm at the conference and there was a lot of people, and I guess that the Wi-Fi started failing. So what we built was Proxy 402. Someone is asking here how many lines you need to change on your backend to accept 402 payments. And reality is that, yeah, you can do it only with one line. So we tried to simplify that, and it was pretty hard. Because the Coinbase team did it already pretty well. So what we did is, instead of changing one line of your code, you put a proxy in front of your code. So you don't even need to touch the code. So I think that we have a video. I don't know if you're going to play it, and I can talk over it. Yes. So you can stop it here 1 second. What you're seeing is already the backend of it. So you just can run this thing. We run an instance for other people. So you can just go to proxy402.com. And after you log in with OAuth, that's what you will see. You will see that you have some live earnings, something similar to Stripe, with the difference that you can put a URL, price, what method the URL is, if you want test mode or not. And sorry, can you stop the video 1 second? Excellent. So in the previous screen, we were seeing like the backend of us. Like you can just copy a URL there, select a price, and then you will get a wrapped link that when people try to access its x402 paywall. So this is the link that we're going to do. This is the paper that started everything, the Bitcoin paper, and it's in Markdown. So we're going to get this link, and if you now click play again, thank you, Ellie. This is just the Markdown. So we're going to take this link. We're going to go to our backend. We are going to just say like, this is the link that we want to wrap. Work with any kind of link. The price is going to be 1 cent. And then we're going to say that this is a get method, like you can do any of the posts, etc. And then that is test mode. After we add the URL to our account, what we get is this new line down here that is all the wrapped links that we have. And then for each one, we have the wrap link, the method that it is, how much it costs, how many people tried to access to it, and how many payments we had successful there. So all this is open source. So actually, if you want, you can just like run your own instance. If we try to access this from the browser, here what we see is like this is the x402 paywall link. So the browser doesn't know how to open it. However, in the proxy, that is the open source code for what you just said. So we also have a client, and that's what I'm going to use for triggering the execution of this, or being able to pay and fetch the Bitcoin paper. So here, if I try to run this wrapped link, what I get is that, well, this is a 402. This is not like the browser. It's a client that understands that I need to pay, and after you pay, like, you are able to access the data there. Now, what I'm going to do is I'm going to change the private key. So for something that doesn't work, just for you to see that if we use the same client, this is test data. So don't worry, even if you steal my key, we're safe. What we get is like we have insufficient funds because we were not able to pay. So the main idea is that you can start playing with x402 even without touching your service, and you don't even need to service for it. You can wrap any kind of URL. So this is a really, really simple way to start playing around this technology, and we plan to make it like easier and easier for people to just jump into it. And that's it. Like the video just show now, like if you go to the nice landing page and how you can log in today. This is a custodial service, as like we are running this. However, if you go to settings, you can put the address that you want to receive the money, so the money never flows through us. And also, if you want, you can even run your own proxy, so you don't need us for anything.
Awesome, that was a pretty cool demo. Great, okay, so I think that is it for our demos. In the meantime, feel free to add any questions in the chat. If you have them, we'll go through them. But first, let's have some questions, or let's ask some questions for the x402 team. So the first question is, why build x402 as an open standard?
You can take that. So I think like the web is an open standard, and the goal is to enable payments on the web. And so it needs to be open by default. Number two is like that's like the first principle baseline thing is like we believe in an open web, and we believe any standard for payments should be open. The second thing is you have this famous like XKCD comic around competing standards, and you have like a siloed standard that isn't trying to build a community and open to all. You end up with a bunch of competing standards that like diverge, and then they're watered down and less powerful than just having a unified standard. So I think that like the value here is really reforming how payments are done on the internet, and that requires like no one to have too much of a thumb on the scale, and for it to be as open as possible so that people agree and buy in.
Thank you. Another question is, what are the plans moving forward with x402?
So we have a roadmap.md in our GitHub. We're talking to a few chains about integrating. We want to add a few new schemes as well that allow for more sophisticated payments that I think are, more robust for things like paying for LLM tokens and more dynamic pricing. And then, other than that, a lot of it is like, what languages do people want? What features do people want? What is the feedback the community is giving us? So, roadmap.md is a good indicator of like our high level direction, and then from there onwards, it's talk to folks, see what's valuable to do.
Thank you. Okay, we got a question from the community, so we're just gonna move through different questions. Ryan asked, tell us more about the x402 facilitator specifically. What does it do? Where does it fit into the payment flow, and who operates it?
The facilitator is an open standard, and so what the interface to a facilitator is part of the x402 spec. And so we think over time there's like a natural ecosystem of different facilitators doing different things will likely emerge. Coinbase has a facilitator that we offer, and it provides like KYT and other compliance things that you need to do if you're going to be accepting money. And so the making sure you're not accepting money from bad actors is a thing you need to do in crypto. But broadly, the facilitator exists to make it easy for people who aren't in crypto to use x402. Like, all the folks in this room have probably built in crypto before, and so it's perfectly valid to just do the verify and settle steps within the application you're building. But it requires having a wallet with gas and access to an RPC node online. And so you can do those things, and you can opt to not use the facilitator. But for folks who aren't in Web3, we wanted to have the facilitator to make it so you don't have to touch crypto at all in order to accept payments with x402.
Yeah, keep the questions flowing, folks. All right, next question is, what has been the most surprising or rewarding part of building this protocol so far?
I can put a bit of feedback in here, but maybe Lincoln can also answer this. I think the most rewarding so far to me has been the community that is already forming up around it, and folks like Jordy and the Hyperbolic team and the Neynar team and everyone else who see the vision and are spending their time contributing and building alongside it. And it's and that's what I think it takes for a new standard to really get off the ground. So really have appreciated the collaboration from everyone in the community, and looking forward to the continued collaboration.
Yeah, to add on to that a little bit too, beyond the community piece, something else that's been particularly fun about x402 is that it's a very interesting problem to try to solve. You have buyers of APIs and you have sellers of APIs, and how do you create the network effects such that every time there's a new buyer with demand, there's a seller there ready to take it? And some of the ways that we've thought about solving this are around the proxy servers, and Jordy's implementation is a fantastic example of that. And there's also this broader network effect that we're going to get from discovery layers and marketplaces of the various different endpoints that are all x402 compatible. So thinking about how this can go from a simple standard to allow your agent to pay for a service into this massive thriving ecosystem with a flywheel, network effects, and all of the things that allow something like this to actually flourish has been very, very satisfying and a really fun problem to think about.
Thank you, Lincoln. All right. I guess an open question is, what is a use case that you're really excited about, but maybe the community hasn't latched onto it yet?
Yeah, one that I've been talking about for a while is the idea of these human-oriented paywalls. Right now, we've primarily been focusing on the AI agent payment use case. I think there's a really compelling narrative for humans pay for services on the internet, especially all of these new vibe-coded games and apps and services that are being created.
Lincoln, your audio is cutting out there a little bit. We can't quite hear you.
Wait, can you hear me better or not?
Yes.
Yes, thank you.
Okay. I see what the issue was. Okay, this should be better. Yeah, I started wandering around instead of using my AirPods. Yeah, all these different games and apps and services that people are vibe coding that don't have a clear path to monetization. Uh, there's a compelling option for X402 to be the paywall that can be used in those situations. One thing that I think would be really cool is for somebody to build some sort of game that has an arcade style retro interface where you pay 25 cents per play or something, and bring back this sort of 80s retro feel to the internet while also having the most modern payment rails imaginable.
Thank you. Anybody else have anything to share on what they would like to see? All right, cool. Oh, we got a question for Eric. You mentioned an interesting use case in blockchain payments and avoiding account creation and API keys. How do you imagine the agents and users behind the agents maintaining access to what they've paid for without accounts or API keys?
It's a great question. And this is actually a piece of feedback we got from the community that we added already to the spec before the launch, which is including a unique identifier to represent the user as part of the response from verify. And so with any of these transactions, you have a UUID that you can use to track to know who is calling you, who is trying to pay for your good or service. In the EVM world, that's like the account address or the address on chain. So right now, I think the way you would go about this is by just using traditional authentication mechanisms and session tokens that already work in the web. X402, I think one of my favorite things about it is that it works really seamlessly with the other paradigms and of the web. And so you don't need to just use X402 as your authentication mechanism. You can have things like cookies and headers and other things that session tokens that live alongside X402. That being said, I do think it's a good idea for X402 over time to evolve a native concept of like a session and a payment. I think what that looks like, we need to kind of think about a little bit. If anyone has any really good ideas, like start an issue on the GitHub and we can start discussing it. But I think broadly, the information is there in order to build a system that doesn't require double payment already on your backend. If you want, that would require using more advanced functionality than just the middleware straight up. And then a more generalized solution should be, I think, something that's included, but I want to make sure that it's done very correctly rather than us rushing it and ending up with something that's suboptimal.
Okay, we got another question. What's your take on adding the support of crypto card either powered by Visa / MasterCard? And someone added on to it saying MetaMask card as well.
I think broadly, if we can achieve the same user experience, I am pro. But the thing with all of the crypto cards is that they're actually just Visa debit or MasterCards. And so Visa has some stuff coming out around like payment tokens, but as of right now, you would still need to like type in a credit card, give your agent access to a credit card to use a Visa / MasterCard card. MetaMask card is the same. And so those things are kind of like, in my view, those things are kind of like a finance 1.0 wrapper on top of crypto. And all they do is take a fee to let you spend your crypto, right? You don't eat the fee, the merchant eats the fee. And so I don't know if it's the right, if they can kind of get to the same UX, I'm not against it, but I don't know if it's the right fit for X402 because of the like user friction, the friction introduced, and the like, it's just another layer of interaction for the underlying assets that those cards wrap.
Thank you. Okay. We got a lot of questions. For agents, sometimes you don't know how many tokens you can use before actually doing the work. Is there a way to do a max approved amount, but actually spend less?
Yeah, so this is we've talked about this a few times, which is what we call our up to scheme. And so I mentioned in the intro, x402 is extensible, that you can have additional aspects of you can add to the protocol different schemes of performing payment. And so the up to scheme is exactly that, where say you as a server respond, hey, I may charge you up to a certain amount. Like let's say for LLM token generation, it's like up to $1. I don't yet know how much that needs to be. And so you as the client sign a permit which says like, yeah, I'm okay with spending up to $1, and then the resource server charges you based on usage. There isn't an example yet of the up to scheme in the repo. It's in our roadmap. The reason why up to scheme is like slightly more complex is because of how permits work and what the message.sender value is on permits. And so there needs to be like a proxy contract that these things run through in order to make sure that the facilitator can actually move funds on behalf of in the way that the payer intends. So we've thought about this a lot, but no demo yet. Soon.
All right. So if a developer team wanted to start working with x402 today, where should they begin?
Definitely check out the GitHub repo. All the demos and everything else that we've shown in various talks and Twitter and other places are all in the examples folder. Yeah, get involved, ask questions in the Telegram. Telegram's pretty active for creators on GitHub.
Awesome. I'm going to link the GitHub again down here. Let's see. Do we have any other questions? There were a few questions that were posted in Discord earlier from a developer that we have. So a question was, do we really need to wait for the full settlement before responding, or can we respond after verifying the payment unless the work is unusually expensive?
Yeah, you can totally do that. There's actually an example in the advanced servers. I believe it's examples/servers/advanced of doing exactly that. So that's like the first place to start, but eventually I think block times come down on most chains, and so I know Base has like a plan to get to 200 millisecond pre-confirmations natively, but you can just opt for lower transactions to respond before you've received full settlement. I see a couple other questions in the chat. Have you guys integrated x402 in the CDP SDK yet? We do really want x402 to be an open standard, and so we wanted it to have its own packaging and APIs, and so we wanted it to not necessarily live within the CDP SDK. So that, but it does work very well with our server wallets and other things in the SDK. But you're not obligated to use them. They just, are good products that you should use. Then Friedberger.etc. How is the project governed? I see that Rosetta API was consumed in a Coinbase API. Will that happen with x402 as well? I think like the analogy I think is probably best is something like Kubernetes, where at first Google kind of shepherded it. That's kind of the role we see Coinbase is playing. And then over time, we move it to like a foundation or something if it becomes like a major success. Right now, that like when a standard is like in its early days, you need some force pushing it ahead. But as you'll notice, like all the code in there is MIT licensed. Folks can fork at any time. All the specs there's nothing tied to Coinbase that's required. If Coinbase stopped running its facilitator tomorrow, other people could spin up facilitators and everything would continue to work perfectly fine. There's no portion that's directly requires Coinbase to be involved for the project to actually work. You plan to host more demo presentation sessions so some devs can showcase their x402 integration in production. Yeah, I think that'd be great. Maybe in a couple weeks we can do something else in Discord, Ellie.
Yeah, that would be awesome. I've already gotten like PMs of folks building some cool stuff already, so it would be cool.
Awesome. Then, have you guys looked into agent-to-agent protocol by Google? Do you have a feeling if it could take off? And if you guys are thinking of adding an example of an integration? Have looked at agent-to-agent protocol by Google. I think it's the problem with agent-to-agent protocol is it doesn't allow agents to pay other agents. And so if someone wants to make a PR with an example of using agent-to-agent payment with ATA protocol, would be a great first contribution.
Alrighty, we're almost at time. If you guys have any last questions, please make sure to post them here before we wrap up. We had a question about facilitator working with base USDC mainnet.
Yep, the Coinbase facilitator already supports base and USDC on mainnet. I believe Lincoln can post a link on how to integrate it. And like we said, it does like KYT and other compliance things out of the box, and it'll give you a nice like reporting for your accountant as well one day. Any last questions?
I see a few people typing.
It'd be great to have a list of items that support x402. Yes, it would. We should have something for you fairly soon.
All right, I think we'll take one more question before we wrap up. Eddie asks, what is the biggest barrier to adoption of x402?
I think like with any standard, the biggest barrier to adoption is getting people to use it. And so there's you need to form kind of a double-sided marketplace of both demand to pay for things with x402 and supply of people who let you do things with x402. And so I think Lincoln could probably speak to how we think about using AgentKit as like one means of generating demand. And then supply is like continuing to find people who are excited about not having to eat credit card fees and deal with API keys and all that fun stuff.
Yeah, it's really a classic two-sided atomic networks marketplace problem. You have buyers who have demand for various different services. You have sellers who also have demand. Incentivizing these sellers to provide the service is one, showing them that they have demand, and then two, demonstrating that there's a very clear path for them to get further discovery and distribution without having to have developers on board, which is the whole thesis behind dynamic agents and what that allows. Agents become autonomous both in terms of their financial access and then also their ability to self-improve, which is particularly exciting.
Alrighty. Maybe we should do this last question and then we can wrap it up. Are you interested in more quantity of transactions or volume with x402 development?
Good question. I think probably I'm more interested in volume, sorry, in quantity of transactions, like volume of transactions, rather than bare currency amounts. I think that the like small transactions are a thing that are uniquely able to do with x402. And if if you're getting like, I'd rather have like 1 million requests a day versus 1 million one request that has $1 million a day. I think like number of transactions is probably a better indicator of adoption.
Thank you. Okay, so that wraps
Unique
up.
active users, Ranko, is what I would goal on. Unique actives.
Alrighty, so we are at time. I want to say a big special thank you to the X402 team for joining us today and answering these awesome questions. To our demo team, thank you so much. We're going to put some links in the chat to the docs, GitHub, as well as website for X402. We also have X402 channel on Discord, where we can continue the conversation. But yeah, thank you all so much. This session is recorded. It'll be posted on the YouTube or our Coinbase YouTube. Thank you all so much. And I hope everybody has a great rest of the day.
So, thank you.